Hi everybody, happy Tuesday. I hope you all had a nice spring break. What we're going to go through in today's lesson are two different ways to prove triangles similar other than angle-angle. So the two methods we're going to go through today are side, 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 and side, angle, side. So the first method we're going to take a look at is side, side, side similarity. So that says if we have three sides of a triangle proportional to three sides of another triangle, then the triangles are similar. So I have two triangles here. And the three sides of triangle ABC are proportional to the three sides of the second triangle. So I'm going to show that by first picking out a side of triangle ABC. So I'm going to take a look at the smallest side, which is AC's length. So remember, proportional means equal ratio. So I'm going to set up a bunch of ratios here. So I'm going to compare side AC, which is 14, to the smallest side of the second triangle, which is side DE, which is 10. And if I reduce the fraction by taking out a common factor of 2, I'd get 7/5. In this triangle, I'm now going to move to like the middle length side, which is 21, which is side AB. And that's going to correspond to the middle side length of the second triangle, which is EF. It has 15. If I take out a common factor of 3, I'd also get 7/5. So these are proportional because equal ratios. So I've compared one pair of corresponding sides, two pairs of corresponding sides. For side, 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 though, I need 3 pairs. So my third pair will be the longest side in the two triangles, which is BC in this one and DF in this one. If I take out a common factor of 4, I will also get 7/5. So since all 3 of these ratios are equal, it means the 3 pairs of corresponding sides are proportional. So I would be able to say that triangle ABC is similar to the second triangle. So I went about naming the first triangle ABC. So I went along the middle length side, AB, and then BC, which is the largest side. So when I name the second triangle, I want to make sure I go in that same order. So I have the middle side and the longest side, so I'd want to go EFD. Remember, order matters when you're naming the similar triangles. So when comparing side lengths in the two triangles, you always want to compare the shortest sides, the longest sides, and then the remaining sides, which are like the middle length sides. So the next example says the sides of one triangle are 8, 14, 12, and the sides of another triangle are 18, 21, and 12. Show that the triangles are similar. So I'm going to start out in the first triangle, picking out the smallest side length. So 8, 14, 12, the smallest side length is 8. I'm going to compare that to the smallest side length in the second triangle, which is 12. If I take out the common factor of 4, I would get 2/3. So this is one pair of corresponding sides. I want to do all 3 though, so I chose the smallest side. I like to next go to like the middle length side. So out of 8, 14, 12, 12 is the middle. 18, 21, and 12, 18 is the middle. If I divide out 6 and 6, the common factor, I'm going to get 2/3. So this is proportional so far. And I want to compare then the third pair of sides, which are going to be the longest sides in the sets, are 14 and 21. If I divide out a common factor of 7, I'll get 2/3. So because I got 3 ratios that are all the same, corresponding sides are proportional. So I would know that the two triangles are similar. The The next one, the second similarity postulate we're going to take a look at is side angle side, or SAS. And it says if two sides of a triangle are proportional to two sides of another triangle and their included angles are congruent, then the triangles are similar. So I have two similar triangles here. I have two pairs of proportional sides, which I'll show you how and why they're proportional in a second. And in between the two pairs of side lengths I'm given, I have congruent angles. So I know that angle B is congruent to angle F because they're both 50 degrees. So that's kind of just given to me that they're congruent because they both have the 50 inside of them. Next, I want to prove that I have two pairs of proportional sides. So I'm going to take a look at, in the first triangle, the smallest side, which is AB, which has a side length of 12. And I'm going to compare that to the smallest side in the second triangle, which is the 8, which is the length of DF. And if I divide out a common factor of 4, I would get 3/2. So I have a pair of angles congruent, the pair of included angles. Here's my first pair of corresponding sides, and I want to show that this ratio is going to be equal to the ratio that compares the remaining pair of corresponding sides. So now I'm going to take a look at this triangle. I'm going to look at the larger side that I'm given, which is BC, which has a length of 24. I'm going to compare that to the larger side here, which is EF, which is 16. If I divide out a common factor of 8 and 8, I'm going to get 3/2. So this ratio and this ratio are the same, meaning I have two pairs of sides that are proportional. I have one pair of angles, the included angle, that are congruent. So I can say that triangle ABC is similar to the second triangle. So when I named the first triangle, I went along the smallest side to the included angle, along the largest side then. So I want to copy that same order when I name the second triangle. So I want to move along the smallest side to the included angle, along the largest side. So DFE would be how I want to name that second triangle. What we're going to do next is just go through a couple of examples, determining if the triangles given to us are similar. If so, I want us to explain why and write a similarity statement. And I want us to be as specific as possible when going through these examples. So, in the first picture, I have side lengths given to me, but I have a side length here, and then I have these two side lengths along the bottom. So the first thing that pops out to me is that the small triangle and the large triangle have angle P in common. So angle P is congruent to angle P because of the reflexive property of congruence. So if I'm going to prove these triangles congruent, it is probably going to be by side angle side. So what I would have to do next is then compare corresponding sides. So in the first triangle, I'm going to look at the smaller side. So I have 4 and 18. So 4 is the smaller side, which is RQ's length. Now, in the larger triangle, I have 8, and the other side that I'm given is not just 6, because 6 is the length of MQ. So this entire side from M all the way to P is 6 plus 18, which is 24. So out of, if we're looking again at the large triangle, it has a side length of 8 and a side length of 24. So the smaller out of those sides is the length of 8, which has the length NM. It's 8, and it would reduce to a half. So then I want to compare the other pair of corresponding sides. So what I'm taking a look at here now is the side length of 18. So PQ, and then PM, again, this entire side of the large triangle is 24. And if I go ahead and take out a common factor of 6, I get 3/4. So these are not proportional. So the triangles are not similar. Another way you could have explained this to me is that the angle that you're given is not an included angle. So we can't use side angle side. So there's a couple different ways that you could go about telling me that these are not similar triangles. One is you can't use angle, you can't use sides. You can't actually use side angle side because angle P is not an included angle. Another thing though I wanted to point out in this example is if you have corresponding sides that do not simplify to the same ratio, like 1/2 and 3/4 are not the same fraction, those are not proportional. So we could also say then that the triangles are not similar. So a couple different ways, but I did want to point out that if you get different fractions when you're comparing corresponding sides, that does mean that they are not proportional. If we move to the next one, the first thing that's popping out to me here is that I have a pair of vertical angles. So angle TXU is congruent to VXW because vertical angles are congruent. Next, I would want to see if I have a pair of proportional sides. So this is an included angle. It is between the two sides that I'm given. So if I can find two pairs of proportional sides, this will be a similar pair of triangles by side angle side. So I'm going to take a look at the triangle on the left first. I'm going to pull out the smallest side, which is TX. It has a side length of 12. Moving to the triangle on the right, the smallest side is XV, which is 16. And if I take out a common factor of 4, I'm left with 3/4. Next, looking at the triangle on the left, I'm going to pull out the larger side, which is XU, has a length of 15. Triangle on the right, the largest side is XW, which has a length of 20. If we take out a common factor of 5, we're left with 3/4. So here, these are proportional because they are the same fraction, the same ratio. So we would say here that triangle TXU, I went along the smallest side to the vertical angle, vertex, and then along the largest side. So I want to do the same order here, moving along the smallest side to the vertical angles, vertex, and then along the largest side, is similar to VXW by side angle side. Again, this is an included pair of angles. Here, we would need to know that this angle was congruent to this angle for these to be the included angle, but we weren't given that. So that's why we could not have used at all in the first example, side angle side. And then the last one that we're going to take a look at, the last two here, we're going to be using side, side, side to try to prove the triangle similar because we are given all three sides of the triangles and we're given no information about any of the angles in the triangles. So what I'm going to do first is I'm going to look at the triangle on the left and pull out the smallest side, which is CE, which has a length of 1.4. I'm going to move to the triangle on the right, pull out the smallest side, which is LM, has a length of 1.6. Those are my dogs. And then because I have a fraction with decimals in it, I'm going to multiply the top and the bottom by 10 to clear the decimal out. Whatever you do at the top, you have to do at the bottom. So that would give me 14 over 16. It's easier to simplify now because I know that these are both even. I have to take out a common factor of 2, which is going to give me 7/8. So that's the smallest pairs of sides. Next, I'm going to move to the middle side. So the triangle on the left, the middle side is CD, has a length of 1.5. The triangle on the right, the middle length side, is NL, which has a length of 1.7. Again, I have decimals within the fractions, so to clear those decimals, I'm going to multiply top and bottom by 10. I can't reduce 15 and 17 anymore. They don't have a common factor. And if I look at these two ratios, they are not the same. So these are not proportional. So the triangles are not similar. So the next one, again here, I'm going to try to use side, side, side to prove these triangles similar. This one's a little bit harder to take a look at, I think, because they share a side. So the triangle on the left, I'm gonna first go through the 3 sides and just label them small, medium or middle, and large. And then I'm gonna do that with the triangle on the right. So the 24 in the triangle on the right is actually its smallest side. This is the middle one, and this is the largest one. So again, I have to go through and pick out corresponding sides. So I'm going to start with the triangle on the left and pull out its smallest side, which is 16. Moving to the triangle on the right, pulling out its smallest side, which is AC, which is 24. If I divide out a common factor of 8, I get 2 over 3. So this is one pair of corresponding sides. Next, in the triangle on the left, I'm going to pull out the middle length side, which is DA, which has a length of 20. Triangle on the right, its middle side is AB, has a length of 30. Divide out 10, the common factor, you get 2/3. So far I'm off to a good start because these are the same ratio. The last pair of sides is going to be the largest side in each triangle, which is AC in the first one to the left, has a length of 24. In the triangle on the right, the largest side is 36. And if I divide out a common factor of 12, I'll get 2/3. So all 3 pairs of sides are proportional. So the triangles are similar by side, side, side. What I have to just make sure I'm careful about is going through and naming the triangles. So I'm going to start by naming the triangle on the left, and I'm going to go from the smallest side to the middle length side. So I'm going to go CDA. So I want to make sure when I name the second triangle, I also go along the smallest side and then the medium length side. So I would want to go CAB. Remember that order matters.